Hey everyone, and welcome to this explainer. I am absolutely thrilled to share this incredible journey with you today. We're going to trace literally the most awe-inspiring path imaginable, starting from the very beginning of time itself and traveling straight to the elements that are sitting inside your own body right now. I know, it sounds a lot like magic, but this journey, which is often called Montessori's first great lesson, is pure majestic science.
So I want to start by asking you to just clear your mind for a second. Can you imagine nothing? I mean, a literal void. Imagine an immensity of space, with no beginning, no end. It's incredibly dark and unbelievably cold. Just to put that into perspective, our darkest night on Earth would be like brilliant sunshine compared to this darkness. And ice? Ice would feel positively hot compared to the freezing void of this space. This was the universe before time even existed. Just pure nothingness.
Section 1, Time Zero, the beginning. Okay, let's dive right into this, because that nothingness, it wasn't destined to stay empty forever. We are stepping right up to the very beginning of the cosmic timeline. Out of that dark, immeasurable void, light was created from what we call a singularity. Now think about this. It was a single concentrated point, smaller than the tip of a pin or a tiny drop of water, yet it was infinitely hot and infinitely dense. This one tiny speck contained the potential for literally everything that is now part of our universe. All the iron, the rocks, gold, water, it all existed right there, just fused together in this vast, flaming intensity.
Now, you've almost certainly heard this moment called the Big Bang. But actually, scratch that. That term is kind of misleading. Since there's absolutely no sound in space, it wasn't a loud, violent bang at all. A much better, more accurate way to think of it is as the Great Flaring Forth. It was this rapid, utterly silent expansion of intense light and heat. Everything just rushed away from everything else in an instant. To really wrap our heads around this, we have to grasp the sheer scale and speed of this expansion. The baby universe expanded faster than the speed of light, and light travels at an astonishing 186,000 miles per second. If you were traveling that fast, you could circle the Earth 7 times in a single second. Just snap your fingers and you've already gone around 7 times. That is how rapidly our universe began to stretch and grow. So as the universe continued to expand, it began to cool down. About 3 minutes after the Great Flaring Forth, the very first elements were formed in a highly specific ratio, 75% hydrogen and 25% helium. And what is absolutely fascinating is that this exact same ratio of hydrogen to helium is still seen today in our universe. It serves as key, undeniable evidence of our spectacular origins. Section 2. The cosmic lung, expansion and contraction. As those early gases filled the void, new fundamental forces took over. I want you to take a deep breath with me for a second. Breathe in and let it out. Notice how your lungs expand and contract? Well, the universe moves in a very similar way. This brilliantly illustrates the primal movements of the cosmos, expansion and contraction. When particles get hot, they expand, they become lighter, and they soar upwards, kind of like a bubble in water. But when they get cold, they shrink, fall, and clump together. As the Great Flare expanded, the force of gravity began to work by contraction, pulling those massive clouds of hydrogen and helium gas tightly together into clumps to form the very first galaxies. Basically, every tiny speck in the universe was given a set of rules to follow, creating what we can call the dance of the elements. Depending on how hot or cold they were, particles settled into 3 main states. In a gas, they move completely freely in all directions. In a liquid, they hold together but roll and flow to fill any hollow space. And in a solid, they cling so closely they form a rigid shape that won't change unless force is applied. This beautiful dance completely governed the early universe. Section 3. The stellar forge, continuous creation. But the universe, it was far from done creating. As gravity squeezed those massive gas clouds tighter and tighter, they ignited. And this brings us to the living, breathing creation centers of the cosmos, the stars. Inside these stars, a continuous process takes place called stellar nucleosynthesis. I know, it's a mouthful, but it's just the process occurring deep down in the core, where extreme heat and pressure literally smash smaller atomic nuclei together with enough force to make them stick. That creates heavier and heavier elements. Stars are quite literally giant cosmic forges. To pull this off, to make this fusion happen, the conditions have to be totally unimaginable. Just to smash hydrogen atoms together to make helium, the core of our own sun has to reach a temperature of 15 million degrees Celsius. That's the tremendous energy required to power a star and forge the basic building blocks of matter.
Now, in massive stars, this process is like a predictable recipe. Gravity constantly squeezes the core, driving the temperature up. First, hydrogen fuses into helium. As the star runs out of hydrogen, the core collapses inward, gets even hotter, and starts fusing helium into carbon. Then carbon fuses into oxygen, oxygen into silicon, and finally, silicon into iron. The star is continuously renewing and recycling matter.
Now, what's really interesting about this slide is how fast things escalate. Fusing carbon into oxygen takes about 600 years. But as the elements get heavier, the star has to burn hotter and much faster. Oxygen to silicon takes just 6 months. And that final stage, silicon to iron, it takes a single day. The star is just racing toward a dramatic and inevitable climax. Section 4. The supernova dispersal, forging the heaviest elements. So it turns out normal stars have a hard limit, and that limit is iron. A regular star simply cannot fuse elements heavier than iron because it doesn't have enough extreme energy or enough neutrons in its core. Once iron is created, the star can no longer produce the outward energy needed to fight against the crushing force of its own gravity. So the core just collapses in on itself in a split second, creating a massive bounce-back shockwave. Boom! This shockwave results in a supernova explosion, unleashing temperatures of 100 billion degrees Celsius. Let that sink in. That is 6,000 times hotter than the core of our sun. These intense, chaotic conditions literally don't exist anywhere else in the universe. Now, it sounds destructive, but this violent explosion is actually this beautiful, necessary sacrifice. Because of that extreme heat and an abundant rush of extreme neutrons, the supernova forges all of the other, heavier natural elements on the periodic table. And crucially, the shockwave pushes all these freshly forged elements, this stardust, out into the empty space of the galaxy. Section 5. The universe in human form. So we've looked at the big picture, from an invisible speck to a flaring universe to the massive explosions of dying stars. But how does this immense story connect to us right here, right now? Well, those clouds of scattered supernova stardust eventually swirled together in a quiet corner of the Milky Way. Over billions of years, gravity pulled this dust into a spinning ball of fiery gas. Following that same cosmic law of cooling and contracting, the outside cooled to form a solid crust. As it shrank, it wrinkled up like an old apple, creating mountains and valleys. Then, it rained and rained for thousands of years, filling the hollow crevices to form our oceans. Mother Earth was literally born from the debris of stars. So the absolutely crucial point here is that the heavy elements needed for life could only be created inside the extreme furnace of a dying star. The oxygen we breathe, the carbon that builds the giant redwood trees, and the iron that runs deep inside your very own blood, they are all stardust. You are made of elements that were forged in the fiery core of an exploding star billions of years ago. No way around it. I want to leave you with this final remarkable thought. When you look up at the night sky, you aren't just looking at the universe out there. You are looking at your own origins. You're not just living in the universe. You literally are the universe in human form. So the next time you look up at the stars, ask yourself, what other ancient secrets of the cosmos are hiding right inside of you? Thank you so much for joining me on this explainer today. Keep learning and keep looking up.